Welcome to part 4 of Competency 16. In this video, we will work with mutually exclusive versus mutually inclusive events. Okay, before we begin, let's look at what we call mutually inclusive events. They are also called non-mutually exclusive events. Okay, this would be two or more events that can happen at the same time. So we have a, a diagram here, a Venn diagram, and we see A, the probability of A, and then we have the probability of B, but we have an overlap where they could happen at the same time. That overlap has to be subtracted out of our probability, okay? All right. And also, another thing that I want to point out is in your answer choices, if you happen to see P, which represents probability of A or B, you know automatically that you need to apply this formula. But we need to be careful about what we're taking out as an overlap. Okay? Then as we move on, you'll see what that means. All right, so number 1, an ordinary number cube is rolled twice. What is the probability of getting a sum of 3 or a sum of 8? Okay, that implies combinations. Now, I've quickly written them out. As you see, the first column, that's if you add it up to be 3. And in the second column, that's if you add up the die to equal 8. Now, please note that the combinations themselves do not repeat from one column to the next. In fact, they do not repeat at all because there is no repetition. We will not use the formula above. This is a mutually exclusive event because we have no repetition with our combinations. Now we can move on and finish what we're doing. But be careful. We have 2 die being rolled. Each time you roll it, you have 6 for each roll, 1 cube. The one roll of the cube. That's a total of 6 combinations. 6 outcomes, excuse me. But you're rolling it twice. So that would be a squared situation. Now, that's the total outcomes for each roll. But then we go over here and we look at, well, we want to talk about summing the 2 rolls to 3. Well, then we have 2 combinations. So what we want is combinations out of total outcomes. Okay. And sometimes people, we have trouble with that because you look over here and you see 2 columns and you say, okay, I have a total 7 outcomes. Well, not really. We're talking about a roll of the dice. So be really wary when you come into that situation. Okay, now, it did say or sum of 3 or sum of 8. So that's addition. Now, when we look at summing to 8, that's still 6 squared. And we have 5 combinations, okay? Now, again, I'm going to say it again so you get it, so we get the understanding. We're asking about what combinations of the total outcomes. Okay, you have to kind of think of it that way. So we have it written out, and this is what we need to put in our calculator. So let's do that. And notice we have a common denominator. And it makes it a little easier to put in the calculator. So alpha y equals, 1 was highlighted, so we have 2 plus 5 over 6 to the second power, enter, and that is 7 over 36, which you probably already saw. Okay, let's go to number 2. Number two, a coin is tossed 3 times. What is the probability of getting exactly 2 tails or getting 1 heads on the third toss? Now it says exactly 2 tails. Okay, so when we start selecting options, which I have typed out over on the right, okay, 2 tails only. All right. So we cannot select the 3 together. So these will be what we need to select, okay? Now it is saying that we need to look at 1 heads on the third toss. Okay, so let's change this. Okay, well, on the third would be these options, not this one. Okay, now we need to look at what we have. We have a repeating situation. Okay. That would be called mutually inclusive. Okay. Now, it doesn't matter that we have 2 situations that do not apply here, here, and here. Heads, heads, tails, and tails, tails, tails. It doesn't matter. They're still a total outcome. They're still part of total outcome. Now, our repeat is 1 out of the 8. Okay. Now that's what we're going to have to subtract in the end, okay? All right. So to begin with, what do we have? We have 2 exact tails. Out of the 8, we have 4. Now we have an or situation, so I added. And then out of the 8, they want heads on the third toss. Well, that's 1, 2, 3, 4. No, 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 no. Sorry, sorry, sorry. I did this backwards. Let's try this again. The exact, exactly 2 tails is the yellow, so that's 3. And then it was heads on the third roll, so that would be 4. Okay, and now minus our 1/8, our one situation that repeats, one combination that repeats. Okay, now we have something we can put in our calculator, right? Where we have a common denominator in parentheses, which makes it a little simpler for us. So alpha y equals, push enter because it's already highlighted. So now we have 3 plus 4 all over the common denominator of 8. Now we can just simply subtract and add another fraction in here. Alpha y equals, 1 is highlighted, so that's what we want, and 1 over the 8. Okay? And it's typed in correctly. And let's push enter. 3/4. Okay? Now, yes, you could have done that in your head because it was 3 plus 4 because they all have the common denominator. They're all over 8. Notice I didn't simplify one because I didn't simplify. You see how easy it can be. You would have 7 minus 1, which is 6 over 8, which is 3/4. But by showing you what I did in the calculator, it also shows you how if the numbers were more complex, then you have, a visual of what you would do. Okay. All right. So let's look at number 3. One card is drawn from a deck of cards. What is the probability of drawing a picture card or a 6? Okay. Now we have to think, do we have repetition? No, we do not. 6 is completely different. Any number is 6. There are 4 6s in a deck. They are not picture cards. So there is nothing to take out. And we are only drawing once. We're not doing a combination of drawing cards. So it's pretty easy to deal with, okay? So we know that this is mutually inclusive. There are no repetitions occurring. Nothing can happen at the same time. All right. So what have we got here? Let's see. It says 1 So we draw one card. It looks like one at a time, and that means that it looks like it's implied that it's replaced also. Okay, so picture cards, there are 12 out of the 52. We're assuming a standard deck. And we have the or situation, which means we add. And then there are four number sixes in the deck of 52. Now, with this question, we did have to do some assuming. One, we assumed that it was a standard deck of playing cards, and we also assumed that there was replacement after you drew the card, even though it didn't say. Okay? Right. Well, now we know what to put in the calculator. Okay? And yes, I'm going to go ahead and use a fraction. Okay, so alpha y equals, that's number one, enter. Okay, I have 12 plus 4, arrow down, 52, push enter, and that's 4 over 13, which is option B. And again, I'm going to remind you that the reason sometimes that for the most part, I'm using fractions instead of just typing in, like 12 divided by 52. I go ahead and use a fraction. That way, it automatically gives me the fraction back as an answer. What I do is I look at my options. If my A, B, C, D options are fractions, I just go ahead and enter in fractions versus saying 12 divided by 52 plus 4 divided by 52. Okay, let's go to number 4. Okay, number 4 says, what is the probability of selecting a retriever puppy with a red coat or getting a 6 when rolling an ordinary number cube? Now, this may confuse you. You may think, okay, well, obviously there isn't repetition. But the definition of mutually inclusive states that it is mutually inclusive if it can happen at the same time. So, can you roll dice and point at a puppy? Yeah, it could happen at the same time. Or you could say, hey, go get a a red puppy, or see if that's a red puppy that was born in the litter while I roll this number cube, I guess. It's a funny question, but it was a question that was asked. Yeah, they can happen at the same time. Okay. So let's see what the probability of the little golden retriever puppy is. And then we'll deal with rolling the ordinary number cube, which is a dice, by the way, guys. Right? Okay. So what do we have? We have 16 in the first column, and that will be plus 4 in the next one, plus, let's see here, we have 5, 6, that's 10. And we add these up, that's 20, 30, 30 total puppies born in 1, 2, 3, 4 litters. And we need the probability of a little red retriever. I guess you say golden retriever. It's a red retriever. Okay, now let's see here. So that would be 10 out of the 30. That's for a puppy. Okay, then we have an or situation, so we're going to add. And then it says getting a 6 when rolling an ordinary die. Well, there's 1 6 out of a total of 6. Okay, now we have to take that and subtract the possibility of repetition of probability. Okay, so I'm not going to reduce this. I'm going to leave it like it is. We're going to have to, we're going to have to say 10 out of 30 times 1 out of 6. Okay. All right, let's put that in the calculator and see what we come up with. Okay. So I'm going to go ahead and use parentheses and just follow through on this one. Okay, so alpha y equals, and that's 10, arrow down over 30, arrow over plus alpha y equals enter, and that's 1 over 6, arrow over, close my parentheses, and we are subtracting, open parentheses, alpha y equals, and this is again 10 over 30, and then we need to multiply, and let's get another fraction, and that's 1 over 6. Arrow over and close our parentheses, double check our entries because I do make typing mistakes. Well, we look okay. All right, let's push enter. And that is 4 over 9, which is correct. Okay, that would be C. All right. Okay, now let's look at number 5 and see what we have here. Oh, we didn't decide. Oops, I'm moving too fast. Okay. Obviously, we had an overlap, and I said they can happen at the same time. If it can happen at the same time, that is mutually inclusive, okay? All right. Sorry, I said it and I didn't circle it. So I want to make it clear. All right. Number 5 has the same thing. So let's circle that after I read everything and make sure we get it correct. All right, let's see what we got going on here. It says a teacher created a chart that divides a box of 36 art supplies into categories of crayons and pencils. What is the probability that the teacher would select a red art supply or get tails both times when tossing a coin twice? Okay, we know because of the puppy retriever situation that is mutually inclusive. It could happen at the same time. Now, let's deal with the not the puppy probability, I'm sorry, the table, which is the color situation. Okay. And it says, what is the probability of selecting a red art supply? Okay, so we have a total of 13 plus 16 plus 7, which equals 36. Now we could put that in the calculator. I did that in my head, but I always say when I'm doing videos, don't do that on a test. So let's not do it right now. Okay. All right, let's push enter. Yes, 36 is correct. All right, so now I have my total, but it says red, and red is 16. So here, let's scoot up and find a little place to write. Okay, so that tells me that, and I'm going to put this in brackets and you'll see why, that I have 16 out of 36. Now I am rolling, it says tossing a coin twice. That's why, let's see, or, and I have an or. Now that's why I wanted to use brackets because we're going to do this twice. So that's 1 out of 2 times 1 out of 2. Close your bracket. Now we have to subtract. Well, I'm going to go ahead and calculate the coin. So we'll have to multiply 16 over 36, okay, times 1 over 4, okay, and let's see what that equals, all right? Okay, so I'm not going to use the brackets. I'm just going to use parentheses, but I used them so I could write the whole process. Obviously, 1/2 times 1/2 is 1/4. Okay, all right, so let's do this. Let's see, parentheses. Okay, alpha y equals enter 16 over 36, arrow over, plus alpha y equals enter, and that'll be 1 over the 4. Now I'm going to go all the way over, close my parentheses, subtraction, open parentheses, alpha y equals 16 over, oops, that's not a 16. Oh, went the wrong way. 16 over the 36. Now arrow over, and we're multiplying. That's something you have to remember, that we are subtracting the duplicate probability actually. Okay, so that's what we want. And 1 over the 4, arrow over, close the parentheses. Now I close them because I like to do, it's a habit, okay? You could just press enter, okay, which is what I'm going to do, but let's make sure I have it typed in correctly. Yes, I do. Okay, enter. Oh, 7 out of 12, which would be option D. Okay, nice. All right, let's go to number 6. Number 6. In a bag of 40 marbles, 15 are white, 20 are yellow, and the rest are green. 2 marbles are selected randomly, one at a time, with replacement. What is the probability that at least one of these is white? Okay. Now, this is a little more difficult to think through, but let's just look at what's really going on here. It says at least one of these. That's a clue. Can we have more than one white as a desired selection? Because it says 2 marbles are selected randomly, one at a time. Even though you're selecting one at a time, it says at least one of these, okay? And you have a replacement. So we can have a repetition of white. We have several white in our bag, and we're only asking for one, so that means we could end up with 2 of them being white, 2 desirable situations, and that is an overlap of probability. So that would be called mutually inclusive because there is a probability of overlap, not necessarily happening at the same time, but it could happen together. Okay, so what do we really need to do? Well, first, let's see what we got here. We have a total of 40. Okay, and it says we have 2 drawings and we're dealing with white, which is 15. But then we have that happen again, exactly the same. It's 15 out of 40. And why is the denominator 40 still? Because we replace the marble. Okay. Now we have to subtract our overlapping. Well, in this situation, we have a pretty easy uh, way to identify what's overlapped. It's the the same thing, the 15 out of 40. However, we're multiplying them together. Okay. So I'm just going to square it, right? Okay. So this could be actually typed in a little easier. So let's do this alpha y equals, because we have a common denominator. Okay, push enter. All right, so we can say 15, we could say times 2 or just plus 15 plus 15. And then go down. Well, it's 40 is our common denominator. So we didn't have to do those fractions twice. So that's good. So now let's subtract. I'm going to use parentheses and alpha y equals again, and 15 over the 40. I'm going to arrow over my parentheses. The reason I'm doing that is I'm simply going to say square it, okay? Which is multiplying the 2 fractions together. I'm squaring them, okay? All right, let's push enter. and I get 39 over 64, which is B. All right. And also, if you look at your A, B, C, D options, they had the probability of A or B. That should have clued me in immediately that this was mutually inclusive. They asked it and also told me so. And then the situation says that it is. All right, let's look at number 7. Okay, let's go all the way down. A particular bag of marbles contains 4 red, 6 green, 2 blue, and 5 white marbles. If 3 marbles are selected without replacement, now it's different from above, without replacement, what is the probability of picking all red or all green? So there's my red, there's my green. Now we don't have a total, but I see 10, 12, 17. So I'm going to go ahead and pop that in the calculator. 4 plus 6 plus 2 plus 5. Yes, that's simple, but like I've said so many times, don't use your brain power for these things. So when I add those together, that's a total of 17. Okay. All right. So this is a different situation. We have 3 being drawn, and that is a collection of 3 drawings to 2 different times. Okay. So it's all red or all green, and we're not replacing. This tells me that our denominator will change. And another thing, we need to decide if this is mutually inclusive or exclusive. Okay? Well, there we have a lot going on here. It's not going to happen at the same time because we have reds and greens. Red and green aren't the same. And then we're replacing. So that once that one probability happens, we're taking away the ability for it to happen exactly the same again because we're taking out the repetition. Okay, so that means we have an exclusive situation, so we won't have to subtract any repeats. Okay, there is no repeat probability. All right, so let's look at the reds. Red is 4. So that is 4 over 17 times 3 over 16. We took the marble out. Okay, now it reduces the situation. Now, the third time, we'll only have 15 marbles and only 2 options. That is all one probability. Now, or they asked, or what about this other probability? Well, let's see, that's for green, and green had 6. Okay, so we still have a total of 17 because we're kind of like starting over. You could call it starting over. Okay, and then we have 6, and then we add, and we have 16, and that's 5. And then we have 15, and then 4. Now, we can put all, I pushed add. Ooh, but you're going, wait a minute, why did you do that? It's multiplying. We're adding the 2 probabilities together. Okay. All right. So let's set that up. Yes, there's going to be a lot of typing involved with the fractions, but I'm going to do it anyway. So open the parentheses, alpha y equals, all right, 4 over the 17. Arrow over, and we're multiplying. Then alpha y equals again 3 over 16, arrow over. Let's do another fraction. Oops. a little overzealous there. I didn't arrow over. Okay, let's do some deleting. Oh, cool. Back where I started. Awesome. Okay, 16. Now arrow all the way over. Be careful. Alpha y equals. And it did it again. All right. Okay. Let's see. I'm going to just start over again. Sorry about that. Okay. Alpha y equals 1 equals 4. Arrow down. 17. Arrow over. And I'm going to multiply. Then alpha y equals. And now I have 3. Arrow down. 16. Arrow over. I need to push multiply. Now I realize the mistake I was making. Yeah, it just wanted to keep going because I didn't push my multiply. Okay. Lesson learned. Alpha y equals in inner 2, arrow down 16. Now let's close our parentheses and add that and open again. And let's go through our process again. But this time we have 6 over 17 to begin. And we're going to multiply alpha y equals, and then we have 5 over the 16. And let's multiply alpha y equals inner, and that is 4 over the 15. And I like to close my parentheses. Oops, I see what I did. I pushed a 5 instead of 4. It's always good to arrow all the way over and get a good look at it. Let's make sure I did this. 6, 5, 4, 17, 16, 15, 17, 15, 16, 4, 3. Okay, well, I'm good now. Okay, let's push enter. And that is 3 over 85, which is option C. All right, good. Now let's go to number 8. Okay. Number 8, 2 cards are randomly drawn from a deck of playing cards in succession without replacing. What is the probability that at least one of them is a picture card? Well, we have that same situation. We have one of them and without replacing. Well, let's see here. Just like the last one, let's see, we have 2 randomly drawn, one after the other. What is the probability that at least one of them is a picture card? Well, that does imply that we have one or the other. That's more like number 6. Okay. And that would tell me that that would be mutually inclusive. We could have repetition because it's saying at least one of them is a picture card. Okay, so let's write this out and see what we have here. It's because you could select a picture card on both times you draw a card. So there is an overlap. So we're going to call that mutually inclusive because we could draw it both times. Okay. Right. And we do have this actually implies an or situation because of the at least one of them. So it's either going to be the first time or the second time or both. So we need to get rid of the or both part. Okay. All right. So let's see here. Picture cards. How many? We have 12. Okay. Out of 52. Now, even though we're not without replacement, because it's the way it's worded, one or the other or both, we do not take out the situation when we're adding the probability. Okay. We go ahead and calculate it. oops, we go ahead and calculate it in our probability. Okay. This is the first time, this is the second time here. Okay, so they're together. When we subtract the repetition over here on the side. Well, what is that repetition? This is where we take out the we deal with the words without replacement is what I meant to say. So we have 12 over the 52 times 11 over the 51. That takes out the repetition. So now we have something solid to put in our calculator. Okay? So actually, I'm not going to use parentheses on the first one because we have a common denominator situation. So alpha y equals and enter. So that is 12 plus 12 over the 52. Arrow over, subtract. Now we need to multiply our repetition, okay? Subtract that out. So alpha y equals, we don't have to use the parentheses if we're going to put it together, just everything across. So 12 times 11 in our numerator and our denominator is 52 times 51. Okay, so let's push enter. And we do get a valid answer, 7 over 17. Now, I do want to point something out to you. In this particular situation, we could have thought of what we didn't want to happen. What if we said what is the probability of drawing a non-picture card? Okay, so just bear with me. A non-picture card, there are 40 of them, okay? And we would not, we would get a non-picture card in the first one, and then it would be multiplied to the second choice, but that would be minus a card, and that would give us the probability for the 2 draws of non-picture cards. Okay, well, that's like the complement of what we just answered for the picture card. So how could we also think of that? We could think of this same situation as the probability of 1, okay, minus the 40 over 52, drawing the non-picture card and, which is a multiply, drawing another non-picture card. Because remember, we weren't replacing, right? And if we put that in the calculator, it will give us precisely the same value, okay? So 1 minus, right, alpha y equals, okay? And now let's do 40 times 39 over 52 times 51. And then, yes, I entered it correctly. Push enter, same value. So that's just another way to look at it. You can answer the question, or you could look for the complement of the question and subtract it out of the 100% probability. Remember, our probabilities all added together always have to equal 1. Okay? All right, let's look at number 9. Okay. 2 cards are picked out of a standard deck. What is the probability of both cards being either face cards or clubs? Okay, now this changes the conditions with this both cards, okay? Now let's think about this. Are we going to have overlapping in our probability? Well, yeah, there are some face cards that are clubs. This does happen, okay? Or we have clubs that are face cards, however you want to look at it, right? So, what we need to look at is we're going to have two cards drawn, and we're looking at both of them, okay? Right, and we have or situation, so that's addition. So we need to look at the probability for both being face cards, okay? And when you draw cards out and we're looking at both of them at the same time, we are not replacing, okay? Which is an assumption, but it's a reasonable assumption in this situation. So we have 12 over 52 because there's 12 face cards. Oh, face cards would be picture cards. That would be Jack, Queen, and King. It depends on who's asking the question. Face cards and picture cards. When people are actually playing cards, they say face cards. What I depends on that. That might depend on, what your family says, a norm. Okay. So then we're going to pick the card, keep it in our hand, and go pick another one. So that's 11 out of 52. And we're going to add that to, okay. Now, clubs, there's 13 out of 52. And we're going to multiply because the probability of both. So without replacing, that would be 12, and this would be 51. And I just saw a mistake. This is not 52. That is 51. Now we have to subtract the repeats. Oh, but as I said, before we really got started, the conditions have changed. What are the repeats? Okay, let's look at this. We're going to multiply. In the first situation, out of the face cards, how many of the face cards are clubs? 3 of them. Okay, remember there's 3 hearts, 3 diamonds, 3 clubs, 3 spades. Okay, that are face cards. All right, so we should say 3 there. Now, if we think of clubs, what is the repetition? Okay, right? Well, there's 3, but we're not, it's still 3, but we're not replacing. Okay, so that means we're down 2 on the numerator and down 2, and then 51 on the denominator. Okay, so yes, and that's the minus. Yes, we are dealing with a repetition, but you're still not replacing. Okay, we have got to put all that in the calculator, all right? Okay, so we have, all right, and you know what? I'm going to do them each separately without parentheses. If you think of order of operations, because each one we can multiply together and separate that with addition or subtraction, we're good to go, or we're very safe with order of operations. So alpha y equals, okay, enter. Okay, so I have 12 times 11 over 52 times 51, arrow over, and we are adding, this is our OR, okay, alpha y equals number 1, and we have 13 times 12, and arrow down, and we have 52 times 51, okay, let's make sure I did that correctly. Yes, that looks good. So subtract, and alpha y equals, and so now we have 3 times 2, denominator, arrow down, numerator, same thing, same numerator all the way across. Yeah, I probably could have put this all in one, uh, and use parentheses in the numerator, but I just think that would be way too confusing. Okay. This way, at least you see each section and you kind of know from the explanation why we're doing what we're doing. Okay. Let's arrow over verify. Everything is entered okay. I would say yes. Let's push enter. And yes, option B looks like that's what we need. Ah, but we didn't establish in the beginning if it was mutually exclusive or inclusive. The fact that we have repetition of face cards, which are also clubs, that is mutually inclusive. Okay? All right, this is the last question in this particular video. I want to thank everybody for watching the videos and liking and sharing us. It is, again, I'll say, I couldn't say it enough. It's really appreciated. And guys, I wish you the best and happy testing.